Hello, this is Miss Moore, and today during chemistry we're going to continue our discussion on stoichiometry. Specifically today we'll be talking about mass-mass conversions. Today's the central question. Given the mass of reactant used, how do you calculate the mass of the products? So for today's lecture you should have available your periodic table, your unit conversion table, and of course your calculators. Well, here's that pesky stoichiometry map again. And for mass-mass conversion problems, we're going to be using the entire map. We're going to be starting at mass known, taking a short break at mole known, mole unknown, and finishing up at mass unknown. We will be using the same conversion factors we've been using all along. So we'll be either using the mole-mole ratio, which is mole known, equals mole unknown, and remember we find that information on the balanced equation. We'll be using 1 mole known equals the molar mass of known in grams, and 1 mole unknown equals the molar mass of unknown in grams. All right, honestly there's not much new here, just an extra step. So really we're just going to do a practice problem together. And the best way to go about this is if you hit pause and try to do the problem without me. See how it goes. I know it's a little different, but not much. So hit pause, see how it goes. And then you can hit play and see if you did it right. Good luck. Okay, so the first thing we need to do is figure out our known and our unknown and where to put things in our map. So our known, we know about nitrogen. We know we have 34 grams of nitrogen. We'll make our known in pink. And our unknown, or what we're trying to look for, is the mass of water. We'll make our unknown in yellow. Okay, so we know we have 34 grams of nitrogen. Grams is mass, right? So in our map, we're going to be starting with mass known. 34 grams of nitrogen. And let's see, we're looking for the mass of water. And again, mass is really grams. So we're looking for blank grams of water. Unfortunately, we can't jump straight from mass known to mass unknown. So we need to fill in the rest of our map. So the next box after mass known is mole known. So it's going to be blank mole. And then our known is still N2. Our known is our known is our known. It never changes. Okay? If the known is N2, it's N2. Okay? And then the next box is mole unknown. So blank mole unknown. Our unknown, it asks a question about is water, so it's still going to be water. All right, now that we have our map filled out, all we got to do is plug stuff in and solve. All right, so let's set up our grid, or at least draw our grid. And I'm going to be careful to try to align it with my map, because I think it helps me to keep from getting lost. And the first thing we're going to do is write what's in the first box, write our known. So we have 34.0 grams of nitrogen over 1. So we've now completed that box. So where do we go from here? Well, we're at mass known and we're trying to get to mole known. So let's check out our equalities and see if we can find something with the words mass known and mole known in the same equality. So looking at our equalities list, we have mole known and mass known here. So we're going to be using 1 mole known equals the molar mass of known in grams. So again, the equality we're going to be using is 1 mole of the known equals the molar mass of the known. So we have 1 mole of the known, which again, our known is N2. So 1 mole of N2 equals the molar mass of the known, N2. How do we get molar mass? Well, molar mass is the average atomic mass found on the periodic table with the unit grams. So N2, well, nitrogen, average atomic mass is 14.01 grams, but there are 2 of them. So that gives us a molar mass for nitrogen, or N2, as 28.02 grams N2. And now these 2 things need to go into our grid. So to decide which one goes where, we look at what we have up at the top in our grid. We have, that didn't work out well, let's try that again. We have grams N2, so down at the bottom here we need to have grams N2, which just so happens to be that guy there. So the bottom is going to be 28.02 grams N2, which means 1 mole N2 has to go on the top. And let's make sure we did this right. So grams N2 does indeed cross out grams N2. And now let's check to make sure we're at the right spot, that we're not lost. So we are right now at mole N2, or mole known, which is where we expected to be at the moment, which means we're not lost, but we're not done. So we have now completed the mole known step. So now we've got to go from mole known to mole unknown. How do we do that? Let's check our equalities. Well, this top one, this top equality, has the words mole known and mole unknown. And remember, that's called the mole-mole ratio, and we get that information from the balanced equation. Okay, so let's do that. All right, so looking at our balanced equation, let's look for our known first. And our known, again, is N2. So that's right there, 2N2. And our unknown is H2O, which is right here, H2O. And remember that inserted between the coefficient 2, or 4, and the molecules N2 or H2O is that invisible coefficient, or that invisible unit, mole. So now we need to put these guys, the 2 things I just circled, into our grid, setting them up so that the units cancel out. So up at the top here we have mole N2, which means down here we need mole N2. So we're going to use 2 mole N2 on the bottom. And remember, that just came right here from the balanced equation. And that means on the top we have to use the other one, which is 4 mole H2O. All right, let's check our units, make sure we set stuff up right. We have mole N2 crossing out mole N2. We are currently at mole H2O, which is where we expected to be at the moment. However, we're still not done. And we finished our mole unknown box, and what we have left to do now is to go from mole unknown to mass unknown. Let's again check the equalities and see what equality has the words mole unknown and mass unknown in it. Well, it looks like this bottom guy here has the words mole unknown and mass unknown. So I say we use that one. 1 mole unknown equals the molar mass unknown in grams. All right, so looking at our map, we have mole, our unknown is mole H2O. So we're going to have 1 mole of our unknown, again, H2O, equals the molar mass of H2O. Again, molar mass comes from the average atomic mass found on the periodic table with the units grams. And this time we have 2 H's and an O. Hydrogens have a molar mass of 1.01 gram. And oxygen has a molar mass of 16.00 grams, giving us a molar mass of 18.02 grams. And let me get rid of this so I can write H2O of H2O. All right, so who are we going to write where? Well, we have mole H2O on the top there, which means we need mole H2O on the bottom to be able to cross out units, which means we're going to use that one. So on the bottom is going to go 1 mole H2O, which means whatever's left over goes on the top, which is 18.02 grams H2O. So let's do one more check, make sure we've got everything set up right. We've got mole H2O, whoops, mole H2O, crossing out mole H2O. We are currently at grams H2O, which is where we expected to be. So yay, we're just about done. All we've got left to do is put this stuff in the calculator. All right, so we're going to be multiplying across the top, which means we're going to be multiplying 34 times 1 times 4 times 18.02 grams of H2O. And if I did this correctly, I ended up with 2450.72 grams H2O. And then we multiply across the bottom, which is 1 times 28.02 times 2 times 1. And I got 56.04. And from there we divide, giving us 43.7316 and some other stuff. Go ahead and round to 2 numbers after the decimal. Our final answer will be 43.73 grams H2O. There you go. Final answer. So, honestly, yes, math problems are long, but it's no different than mole or mass mole or mole mass. Just be careful, use the map, you'll be fine. All right, that's it for today. Have a good one.